Hello class. So today you might notice something a little different about the interface of this video is I'm actually recording my screen right now because we'll be using our graphing calculator, Desmos, and I just kind of wanted to show you a few things about it today. Today we're on 1.2, what is a function, and we're going to be evaluating functions. So let's get right into this. So what is a function? A function a function is kind of like a machine where you plug something in and you get something out, right? And it's one-to-one. So a function must only have one output for every input. So for instance, if I plug in 4, right, I can't get both 8 and 3 as an answer. I must get one specific answer. So if I plug in 4, I can get 8, or I could plug in 4 and I can get a 2 in a different function, but I can't get more than one answer. So a function must only have one output for every input, which means it must pass the vertical line test. Which means it must pass the vertical line test. And I'm sure I think I'm sure, I don't know, that you guys probably did this freshman year. So we're kind of going back to older mathematics that we've worked with before, but doing more with it, obviously. Let's say if we have a function here, or a graph. So let's take a look at an example. And right now it doesn't really matter what are the actual equations for these graphs. Just, I'm going to show you guys what I mean by this. So say we have a function that looks, so let's see, what color should I use? I'll use purple, okay. Like this. And then a function that looks like this. Well, the vertical line test, this is what it means. You want to take a vertical line, remember, straight up and down, and go from left to right across the whole equation. Well, the whole equation, I mean a good, all of that, what's given, because equations go on forever. And you want to make sure that as you go from left to right, that your equation only touches, or your function only touches that line, that vertical line once. So in this case, my vertical line will be this ruler. And let's see, as we go here, the function's going up, it's going back down, and so far, it's only touching it once the whole way through, right? So because it only touches the vertical line once the whole way through, this is a function. But let's take a look at this one on the right over here. We started from the left. It touches once, touches once, touches once, but then right when we get right here, it touches once, twice, 3 times. So basically what that is saying is when we have our input x, at this input, we're not going to have one answer, we're going to have 1, 2, 3 different y value answers, which means that this is not a function because it does not pass the vertical line test. Okay? So let's take a look at what your worksheet will kind of look like for these kind of problems. You're going to have something like, let's see, what I don't even know what color I'm using anymore. We'll use green. Let's say we have something like this. Y equals 3x squared minus 2. And all we need to do is see if it passes the vertical line test, but in order to do that, we need to graph it. Now, I know we don't have graphing calculators, so I'm going to show you all how to graph on Desmos. So Desmos is a website online, and I already have it pulled up here. You can just go to desmos.com/calculator, or just desmos.com and then click the button where it says calculator. It'll bring you right here. So on the left here, you see, well, I already have this part set up. I'll just, when you first get here, it'll bring you something like this. This is where you want to put your functions to graph it. So let's put our function. It was y equals 3x squared minus 2. And we have our function right here. And we want to see, does this pass the vertical line test? And really quick, I'll just make a vertical line. So negative 10 to 10. Okay. And here's my vertical line. I'll kind of make a different color so it's easier to see. I can do that. And we want to see, does our function only touch this vertical line once at every point? And yes, that is the case here. And if you're not sure, you could always zoom out. These are the zoom in and out buttons. Zoom out, and yeah, it looks like that's still the case. I know it's pretty squished, but you can still see that it only touches once. So this is a function, because it passes the vertical line test. And if you're happy about it, you can put an exclamation point like I did. All right, let's take a look at a different one. What about something like this? X squared equals y squared plus 5. Now, you'll notice that in this function, we're not solved for y. And normally on your calculators that we have here at school, these TIs, remember these bad boys? In order to put it into the calculator, we would need to solve for y. But that's not the case with Desmos. Desmos is much more powerful than these calculators. So we can actually input it just like this. So I'm going to go back to Desmos. I'm going to erase my function and put in my new one, x squared. What am I doing? Equals y squared plus 5. And this is our function here. It kind of looks like an x. I'm going to zoom back in. An x that doesn't really touch. But does this pass our vertical line test? And we can see right off the bat it does not touch the vertical line, or it does not pass the vertical line test, because there are places where it touches twice, like right here, and it actually does that through mostly the whole function, right? So this is not a function because it doesn't pass the vertical line test. You could put a little sad face if you'd like. I don't know. It looks kind of like a fish face. But that's that. So that's how we know of whether a function is a function or not, whether it passes the vertical line test. So let's move on here and talk about how to evaluate functions. Well, evaluating functions is just really plugging in a value for an x and simplifying. That's all that evaluating means. So to evaluate, a function, plug in an x value, and simplify. That's all that evaluate means. So let's take a look at an example here. Examples galore, right? There's a lot of them. Okay. Let's try a new color here just for fun. Let's say that we have f of x is equal to 2x cubed minus 5x squared plus 3x plus 1. And we want to find f of, let's see, we want to find f of 2. Well, all we're going to do is plug in 2 in for x every time we see an x and simplify. So f of 2, and remember this part is just notation. This part is saying we're finding the function f when x is 2. I just plugged in 2. And let's see, 2, I guess I can plug in the 2 there for that x. Plug in the 2 here for that x. Plug in a 2 there for that x. And plus 1. And just simplify. So remember how to simplify. We want to we want to follow the rules of operations, really, parentheses or grouping, really, then exponents, multiplication, division, addition, subtraction. So I see we have nothing. The parentheses inside the parentheses are already simplified. So let's go on to the exponents. So 2 times, let's see, 2 cubed is 2 times 2 times 2, which is 8. So 2 times 8 minus 5, and then 2 squared is 2 times 2, which is 4, plus 3 times 2. We can just go ahead and do that right here. That's because let's just keep it like this, and then we'll do it all. Our multiplication in the next step. So now that we got rid of our exponents, let's do multiplication. That is 2 times 8 is 16, minus 5 times 4 is 20, plus 3 times 2 is 6, plus 1, and then finally addition and subtraction. 16 minus 20 is negative 4, plus 6 is 2, plus 1 is 3. So f of 2 is 3. Let's take a look at another example, because some of these will begin to look a little differently. Let's say that we now have f of x is equal to 3x squared plus 4x minus 1 divided by 4x plus 3, and we want to find what is f of negative 3. Well, again, we're just plugging in x, or we're plugging in negative 3 for every x we see. Let's go ahead and do that. So f of negative 3 is equal to 3 times negative 3 squared, I just plugged it in for that x, plus 4 times negative 3 minus 1, all over 4x, well, we're plugging in negative 3, so it's going to be 4 times negative 3, oop, I should have done that in blue, whoops, plus 3. And now we simplify. So remember, I think this is the first or second day we worked with fractions. We want to simplify the top, simplify the bottom, and then divide if we can. If not, we'll just leave it as a fraction. So let's see here. F of negative 3 equals, let's do the exponents first. So 3 times negative 3 squared is going to be negative 3 times negative 3. So that's going to be a positive. Remember, negative times a negative is a positive. So that's going to be positive 9. And then plus 4 times negative 3. And if you want to do all this stuff in more than one step, you can. I'm just doing it one step at a time. Now let's do multiplication. Let's see. 3 times 9 is, oh boy, 27. 4 times negative 3 is negative 12, so minus 12 and minus 1. All over 4 times negative 3, again, is negative 12 plus 3, and we're getting there. 27 minus 12 is 25, minus 1 is 24. Negative 12 plus 3 is negative 9. And just like that, it's kind of getting behind that. And if you want to write it a little nicer, you can just throw that negative out front. It's a little more official. So our answer is negative 24 over 9. And if you want to reduce, you can. We can take a 3 out of both of these. Taking a 3 out of this would be negative 8/3. But I'd be fine if you just left it at negative 24/9. Let's do one more example, because we'll get kind of a different form as well. And say we have something that looks now like this. G of x, that's not what's different, it's, like I said, it's different, but it doesn't really matter, is equal to the square root of 2x plus 15. So let's recall square roots, right? And we want to find f of 5. Oh, I never wrote the answer up here. Negative 8/3. Okay. We want to find f of 5. Well, let's plug in 5. So g of 5 is equal to the square root of 2 times 5 plus 15. And then just simplify. So we want to simplify under the square root first. Once we have simplified under the square root, we can then see if we can take the square root. So 2 times 5 is 10, plus 15. We can add those together. 10 plus 15 is 25. Square root of 25. If the number down here is not a perfect square, just leave it just like that. But since it is, we can take the square root. 25 is, the square root of 25 is just 5. So our answer, f of 5, is equal to 5. And that's that. I'll be here. If you have any questions, just let me know.